let's go with Module 4, Data Quality and Data Relevance. One of the best resources I came across throughout my career and education is actually by a education and statistics scholar, Jason Osborne. So I would definitely use this as a resource and a reference in terms of best practices in data cleaning. He has this statement here at the beginning of this book or this resource. And so why should you read it? Because there are important steps every quantitative researcher should take prior to collecting their data to ensure the data meet their goals. Because after collecting data and before conducting the analyses to test hypotheses, other important steps should be taken to ensure the ultimate high quality of the results of those analyses. I refer to all these steps as data cleaning, though in the strictest sense of the concept, planning for data collection does not traditionally fall under that label. So he's actually going a step back from once you have data to emphasizing the need to think about it or consider the quality of our data, right? And the reason behind all this is that obviously we're going to at some point empirically test a hypothesis, and we don't want to make an incorrect conclusion or suggest there is a pattern or relationship when there isn't. So, I think it's a more mind-opening perspective to start thinking about that before you even collect data, right? What are some of the potential quality issues that I may face or come across? Am I being comprehensive in terms of my data collection or my thought process around data collection? So it's a good resource for you to reference. And obviously there's a lot of possible steps we can take in terms of pre-processing data, but the idea is that we're trying to get our data ready for analysis and ultimately to do our empirical testing, right? To get those results that help address our original business problem or business question. So you can see there, this is actually from a textbook that I've used for a number of courses, and you can see there's this diagram that sort of shows the pre-processing steps, right? So you have raw data sources coming in, that data is not ready for analysis. We might need to consolidate data, then clean it, including filling in missing values, dealing with outliers, removing duplicate records. We may need to transform the data, so we may need to normalize, make variables that are continuous and numeric or quantitative to categorical, or discretize data. We might need to create other variables or other attributes, and then we may need to reduce the data. So this is a good high level view. In my experience, approximately 70% of the time is actually spent putting together and pre-processing data that is now ready for analysis. So the actual analysis part actually takes a lot longer than the preparation part. There's a lower estimate for one resource there that could be around 45%, right? But it's still a very large portion of the project is actually pre-processing, cleaning, and then transforming that data, so that you can actually use it for analysis. And there's more detail here from that resource on pre-processing around the methods or the potential methods that could be used. So under data collection, you actually see SQL. So we'll talk a little bit about SQL later on in a subsequent module. So queries help with data consolidation, also data cleaning. In some instances, we may fill in missing values, and we might impute those missing values using maybe the average or the median from records or fields that we do have non-missing values for. We may need to eliminate or sort of replace values that are outliers, right? Again, we might see something so extreme that we basically might deal with it like as if it was a missing value, right? That the value itself is essentially so extreme that we're going to set it to missing and then impute that value or fill it in. We might eliminate records, as I mentioned. In terms of data transformation, normalizing, we might need to put everything on the same scale. In terms of discretize, I mentioned we might convert something that's numeric to categorical. We also might create new variables that may be helpful for our business question or business problem. We also might reduce, for reduction, we might reduce the number of attributes or dimensions that we're considering. We might reduce the number of records. And finally, we might balance skew data. That's more so if we're trying to differentiate between, let's say, two groups, group 1 and group 0, and we have too few in group 1, right? Let's say we have 10% is group 1, 90% is group 0. To say anything meaningful about differences between 1 and 0, we would actually have to maybe balance out our analysis, so it's maybe more of a 50-50 balance, right? So we might oversample that group 1 because at initially it's underrepresented, right? So we want to sort of balance those out. Yes, this is the simplified process. We are basically importing raw data, right? We keep it in its raw form. We tidy that data or put it into workable form. And that process, one term that's used, it's called data wrangling, right? So we're getting that data ready for analysis. From there, we may transform. That's where we maybe filter data, create variables, and we may then also visualize the data, right? So visualize the data. We may also develop from there a model where we have a clear dependent variable and an independent variable or independent variables, and then we communicate and share those results. So pretty much all of that requires some technical knowledge, and obviously we can see there we're taking data, we're analyzing it, and then we're communicating those results. So all that would go into or would be required for a data project. Okay. So missing data, and there's actually some lessons we can take away from these categorizations of missing data. And really what we can see here is that there's missing completely at random. There's data that's missing in a way there's really no pattern, right? There's no pattern. Could be software based or system based. Could be human error. Could be that data was deleted on accident or wasn't saved accidentally. There's missing at random. So some variables have missing values or a decent amount of missing values, and others don't. Meaning that the missingness depends on known data in the dataset. And it could be due to dropout, right? I mentioned, for example, in even in a longitudinal study, there could be challenges with continuing to follow up with a certain household or certain individual. So there could be some challenges there. It could also be that there's certain maybe questions that in a survey setting that people don't answer or don't answer in a consistent manner. And then finally there's missing not at random. And these are due to factors that are related to the missing value itself, meaning the missingness depends on some unobserved data. In this case, there could be sensitivity to certain questions in a survey setting. Could also be there's some non-response in an experiment setting. In what you can see here, the rightmost column is that there's different methods to handle missing values in this case, right? The hope is completely at random. In that case, there's no systematic explanation for why certain data is missing. But there could also be reasonable explanations. There also are other categories of missing data, and some lessons we can take away from these categorizations. So it could be structural missingness. Data could be missing because it's logically undefined for certain records. It could also be systematic missingness. So systematic issues or external constraints. So it could be data collection errors or exclusion of certain groups, right? So that would be a big one that we could be concerned about, because it would suggest that our data is not really representative of the group or overall group or population that we're trying to study or reason about. There could also be intermittent missingness. So that could be data that's missing sporadically in, say, a time series or longitudinal data sets. Again, we know what that means, right? Time series and longitudinal. So it could be that maybe a certain time period, right? The cause could be a certain event, right? Maybe the power went out for a week, or the system was down, or there could be some sort of time element or time explanation. But we have maybe most of the data, but certain time periods there's a gap for that specific time period. All right. So let me just translate this, because that is a little bit more technical. And so we think about the practical explanation. I sort of bucket it into three groups, right? The three logical groups. The first one being human-driven, and under that, there's interaction with software. So it could be that maybe individuals that are interfacing with software systems are not fully trained on how to use that software system, or maybe using codes or mechanisms that they're not necessarily supposed to be using, and it could then in our database show up as unreliable, right? Unreliable data, or data that maybe is not quite measuring what it's supposed to be measuring. Another reason would be manual, right? This could be mostly human error. So in that setting, it could be that someone, if they're entering data, right? Let's think data entry. They could press the wrong number on a keyboard. That would be a source of error. Also on, in a setting where we're maybe surveying someone, let's say a customer, it could be that they actually are incorrectly answering or responding, right? So in that case, let's say I am filling out a survey and it's a bunch of agreement level questions, and if I just select on a 1 to 7 scale, 7 for every question, I probably did not think and did not put any effort into answering those questions accurately and responding accurately, right? So that could be another source. So machine, software, or computer driven, that's where, in terms of data and data quality issues, and again, we're talking not just missing values, we're talking other potential challenges in terms of the accuracy or representativeness of our data. It could be that maybe the software malfunctioned, or machine malfunctioned, or a computer was maybe, or computer or machine software, things were being stored in a way that they shouldn't be stored, or captured in a way they shouldn't be captured. So that would be mostly machine or software computer driven, right? Or maybe a backup that was supposed to occur didn't occur. So that's one source as well. The third would be when you're sort of in a more of a consulting setting, right? You're not the owner of the data. You're not overseeing. You don't have direct access. You may ask for access or ask that owner to provide you with that data. Well, it's possible that maybe they didn't provide you with the right data. In other words, they may have made a coding mistake or query mistake in which what they provide or queried for you is not what you necessarily want or needed, right? So those are sort of my 3 practical categories. It's like, what could cause this issue? And I sort of think to these three areas. And the reality is that humans are messy. We create data. We interact with data, interface with data, and so that could definitely be a cause or potential reason for us getting maybe not the best data that we would want, or the ideal data that we would want to address our business problem or business question. So finally, outliers. There's a lot of emphasis on sort of extreme values or outlier values. And I just wanted to give you a practical example. Obviously, Malcolm Gladwell has a book about people that are very different from the typical person, right? So that sort of folks that have been very successful to a sort of exceptional point. But let's think of the average worth of the 10 wealthiest people, and this is sort of my punchline in terms of what we want to think about in terms of the data and how that might impact or influence our results and our conclusions from those results. So you can kind of see here, I have 10 individuals, the 10 wealthiest people. If I take the average in terms of net worth, that's about 192 billion, right? And obviously there's two individuals we know, right? Elon Musk from Tesla and SpaceX, and then Jeff Bezos from Amazon. If I take those two people out, right, I would say that those folks are on the extreme end, right? Especially Elon. That average drops to 159 billion. So my point here is that data can influence the end result, right? Here I just took a simple average, but when you start thinking about if you're trying to build a predictive model or do a statistical test, that you may also then get, based on your data, very different outcomes if certain records existed or did not exist, right? Or certain values existed or did not exist. So it's an important thing to consider. In this case, this is a special example, and an example that is also teaching point is that sometimes these records are very much legitimate, right? Elon Musk and Jeff Bezos should be there, but they're just very different from, well, us, and then also many of the folks on that top 10 list. So hopefully you've taken away some good lessons around the need to make sure we look at the quality of our data, the representativeness of our data, and sort of appreciate that is a science, and it is up to us as the analyst. The important thing, though, that I want to also emphasize is that if we do make any of these adjustments or do any pre-processing, in this case I dropped two individuals, we need to report that, right? So we need to report our assumptions, we need to report that we dropped certain records, that we did any imputations or fill in missing values, that we changed the value for any outliers, we filtered the data. We need to report that so that the consumer of our results knows that information, right? And so then they can make their judgment based on knowing that information on what these results represent from a data perspective. So that would be the end of module 4.